We're going to go ahead and start recording again and move on to that next page. So residuals in the least squares regression line. In most cases, no line will pass exactly through all the points in a scatter plot. Because we use the line to predict y from x, the prediction errors we make are errors in y, the vertical direction in the scatter plot. A good regression makes the vertical deviations, we'll talk about this in a second, so don't stress out about it too much, of the points from the line as small as possible. And I'm going to show you in just a minute, so hang on. The scatter plot below shows the Ford F-150 data with the regression line added. The prediction errors are marked as bold segments in the graph. These vertical deviations represent leftover variation in the response variable after fitting the regression line. For that reason, they are called residuals. So what it's showing, again, you see all the dots that were on the scatter plot for the F-150, and then you see the prediction line that we had, and then you see these vertical lines that are touching or connecting the dot to the line. That is how good of a prediction it is. Those vertical lines are the residuals. How far away, like how tall, is it from the line? So is it 3 units above the line, 2 units below? Does everybody see that? That's all that is showing you, and that's all that's saying. So each vertical line is how far it is from the predicted, okay? So the actual versus the predicted, okay? A residual is the difference between an observed value of the response variable and the value predicted by the regression line. So this is the formula for residual. Your observed y minus your predicted y which is actually y minus y hat. I just say the actual minus the predicted. So it's whatever you can remember, okay? All right. So this number is screwed up. This should be a 7. Find and interpret the residual for the F-150 that had 70,583 miles driven and a price of $21,994. So this is your actual. This is in the scatter plot. We need to find the predicted. How do we find the predicted value?
Y equals A plus BX.
Okay, do we have that equation already?
Kind of, yes.
Yeah, we're using the same problem. It's the same exact problem. So we already have that equation. So this didn't come from anywhere crazy. It's that same equation that we've been using this whole time. So y hat equals 38275, 382, sorry, 57, 57 minus 0.163x. So we need to find the predicted. So we're going to plug in how many miles driven, how many miles has this truck been driven? Perfect. And I'm going to go ahead and tell you that gives you 26759. So the predicted price is $26,759. It wants you to find the residual. So this is just part one. This is the predicted price. So to find the residual, you do the actual minus the predicted. What was your actual price? $21994. What do we predict our price to be? That's a difference of negative 4765. All right, so it's not good enough just to find it. What does it say to do? Interpret it. What happens when I have a negative 4765? Guys, look right here. What do you know about the predicted versus the actual?
The actual price was lower than the predicted. It was $4,765 lower.
The actual price of F-150 was $4,765 lower than predicted. That's all you got to do. That's it. You could say the predicted price was $4,765 higher. It doesn't matter as long as you get it the right distance. Okay. You're going to flip it when you're done. This page is really quick. One of the first principles of data analysis is to look for, oh, this is not the right page, sorry. The regression line minimizes the sum of the residuals. If we add up the prediction error, there's a lot of mistakes in here. Should say 4. 16 trucks, the positive and negative residuals cancel out. This happened when we tried to measure deviation around the mean. To get around this, we square the residuals. So again, all these residuals will cancel each other out. So the way we get them to not cancel out is we square them so that it makes it all positive. Does everybody understand that? So if we don't square it, we have positives and negatives. If we square it, we have all positives. So the least squares regression line or you'll see it as LSR of Y on X is the line that makes the sum of the squared residuals as small as possible. This, I think, and I could be wrong, is a multiple choice question. Okay, on your test. I've given so many, I know it's on one version that I've given. Okay, so just be aware of that. All right, so to check your understanding on page 172, it asks you to do this formula for the regression for SEC football data that we've already done before. How do we find that regression line? Tell me the steps to do it. I'm sorry, Zoomers, don't answer. How do we do it? Stat edit, what do we put in? Into L1, L2. Somebody else, where do we go from there? And then somebody else, where do we go from there? To number 8. And then we just write it down. Is everybody good? Okay, so I'm going to go ahead and tell you what that prediction equation was. Remember, we can write it like this. But we have to define our variables, okay? We have to define our variables. So y hat is the predicted winds. And our X was points per game. Remember, we talked about this a lot where we said the higher the points, the more wins you should have. Okay, so this is where it's coming from. What's your slope?
0.4372.
Somebody in class interpret that for me. If you can't interpret it now, you'll never be able to interpret it on your quiz or your test. Maybe I should give a quiz sometime, like a for real quiz. Don't make it too hard. This is just like Math 1. What does a slope mean? Okay. Zoomers. Interpret your slope.
Every point you get 0.4372 more wins.
Both ways are correct. Okay. Both ways are correct. It doesn't matter as long as you say that it's going to increase. Okay. All right. What's your y-intercept?
Would you have to say per wins, or could you say per game? Or would it be per wins?
It would be points per game. The predicted wins increase 0.4372 points per game.
Okay, gotcha.
If I even said, I don't even know if I said that right. Keep going. What's your y-intercept? Negative 3.7506. Somebody on Zoom interpret that.
It's the predicted amount of wins for like a team that scores 0 points.
Yeah. So is there a chance that they could win -3 games?
No.
No. So this is a little bit unrealistic, but something is throwing that data off, and we'll talk about that later on. Good job. Make sure you know how to predict, okay? All right. Front and back is the last of this. So one of the first principles of data analysis is to look for an overall pattern. And for striking departures from the pattern. A regression line describes the overall pattern of linear relationship between an explanatory and a response variable. We see departures by looking at residuals. Okay, so remember we talked about we're not real sure if we have outliers or not. What is it going to be? So this will tell you how to do that. So the predicted price of Ford F-150 with 68,474 miles driven is, remember we do predicted price. This is the same formula we've been using. Equals 38257 minus 0.163, and we're plugging in the miles, 68,474, which gives us 27,103. Okay, so we know how to do that. That's the easy part. So let's review the residual. How do you find the residual? What's the formula for residual?
Actual price minus predicted.
Actual minus predicted. They gave you both. Well, we found the predicted, but they gave you the actual. What was the actual? It's in the chart. Okay, so don't freak out. I'm not going to make you flip back. But the actual price was in the chart. Is everybody good with that? Okay, so that actual price. Oh, sorry, that's not a hat. Was 33961. I did not pull that out of thin air. It was from the chart in the very beginning that we typed all our stuff in, Lauren. Minus 27,103, which gives us a residual of what? Thank you. Perfect. So the truck cost $68.58 more than expected based on mileage. The 16 points used in calculating the equation of least squares regression line to produce 16 residuals. So 16 points, 16 residuals. Rounded to the nearest dollar, they are this. Remember in L1 we put in miles. In L2 we put the price. It was the actual. I'm going to show you how to do residuals on your calculator. In L3, you will put in your equation, 38257 minus 0.163, but you're going to put in L1, okay? I'm going to show you how to do it in a minute, okay? So just write it down for a second, and then we'll do it. Remember, this is your predicted value. And there's a reason I'm telling you that, okay? So L2 is your actual. L3 will be your predicted values. And then L4, you're going to put in L2 minus L3 because this is your actual came in L2 minus your predicted in L3. Okay. So you still have your data in, right? Into stat. You're actually going to go up on L3. I hit enter and it drops my little box down there on the bottom. And you're going to type in what I have, 38257 minus 0.163. And then to get L1 in there, you have to do second and 1. Second 1. So it looks like this. When you hit enter, it will fill in your chart with a bunch of values. Okay? Is everybody good? What are those values? What did I tell you they were?
The predicted.
The predicted. Those are the predicted prices used in our equation. To find your residuals, you have to do the actual minus the predicted. So we're going to go up in L4, hit enter. The actuals came from L2. The predicted were in L3. This shows you all of the residuals. So when we were sitting there having to calculate each one, you can do it all by yourself. Like the calculator will do it for you, so you don't have to do it. So you may want to remember this. So you might want to start. The residuals from the least squares of the line have a special property. The mean of the residuals equals 0. A residual plot is a scatter plot of the residuals against the explanatory variable. Okay. Which one are our residuals? Where do we find our residuals in here?
L4.
L4, okay? So when we go up to stat plot and we turn this plot on, L1 is our X, is our explanatory. L4 is our residuals. Is everybody good? So I'm teaching you how to make a residual plot right now. When I graph that, you guys see this? Is there a pattern? No, it's just scatter, right? That is exactly what you want. Okay.
Did you use Zoom 9?
I did, but I might, yeah, I have something in, sorry. Doesn't matter, it's still gonna give you kind of the same. Is everybody good? All right, so residual plots help us to assess whether a linear model is appropriate. So this is your linear model that we just did. This is the scatter plot of the trucks. This is the residual plot that I just made in your calculator. Flip it over, last page. You do not want any pattern in your residual plot. If you have a pattern, and we'll talk about this more tomorrow, if you had a pattern, the line of best fit is not a good fit. Okay, and we'll talk about that more soon. So find the residual for the truck that had 8,359 miles and driven at a price of $31.89. So we can go back in our chart. We're looking for the 8359, which is right there, 31891. What was our residual? What was our residual? Okay, how would you show your work? You would keep that point, you would predict, plug it into the prediction line, and then subtract it. I'm not making you show your work because we've already done it and I'm wasting all your time, okay? So just make sure you show all the work. Interpret the value of this truck's residual in context. What does this mean? What about the actual price?
The price was $5,003
Oh.
higher,
Mm-mm.
lower than what was expected.
Yes, actual is 5,003 less than predicted.
Oh, I was reading it backward.
You can write it the other way too, it doesn't matter. And then number 3, for which truck did the regression line over predict by the most? So over predict means what kind of number are we looking for?
Really high.
Are we? If it's an over prediction,
Oh, just the one that's like furthest from zero.
in which direction?
Either.
Mm-mm. An over prediction, yes, we want negative values. It's an over prediction, so that means when you do your actual minus your predicted, we want an over prediction, so this number would be bigger, causing a negative number. Does everybody see that? Y'all understand what I'm saying? All right, so I want the biggest negative number that I can find. So if I'm looking through this, what's the biggest negative that you saw?
Negative 8,116.
Good. So again, we were looking for the largest negative value. So it's the F-150 with how many miles? So find that number in your chart, negative 8116. How many miles did it have? Okay, I'll just write it down. 44447 miles. Don't complain when you don't understand this and you're not participating in class. Y'all, you can't learn it if you're not actively participating. Okay?
Ms. Jones, I have a question.
Question away.
So in the calculator, we put L3, we put that equation, but then minus L1, right? Like for where the miles would be. All right, well, I had like the right points and then I put in that, but I'm getting numbers that are like in the negative 30,000.
What did you put in?
I put in the,
Those of you on Zoom, if you're, let me see this last name right there. I'm glad we're adults here. Rachel, what you put in? If you're good, Zoomers, you can go.
I put in the 38257. Well, because like I know the data's right because we had the same like the same linear regression stuff on there.
Right.
And then I put in the 38257 minus 0.163 and then L1.
Mm-hmm.
And then for L4, I have the L2 minus L3. And then I'm still getting numbers that are like, I don't know. I'll figure it out later.
No, don't. Check and make sure that you didn't just put in crazy, like, all right. So,
Okay, never mind. They fixed themselves that time. I don't know. I read it like 4
Okay.
times while you were talking, but I guess I was just clicking something wrong. All right, thank you.
okay,
I have a question about the notes too.
okay.
2 pages back, it says something about, I gotta find it real quick. Above the 2 graphs next to each other.
Which ones?
Just the one where it has like a bunch of squares in the right graph.
Yeah. Mm-hmm.
Up above that, where it's talking about residuals canceling out, it
Mm-hmm.
says this happened when we measure deviation around the mean. Like, what is that talking about?
So to be able to use this, like your residuals are always going to cancel out. So that's why your mean is 0, because they cancel out, and then you divide 0 by whatever number. Hold on. Let me. All right. Your residuals added up, like all of those residuals will add to 0. Doesn't matter how many you get, they'll always add to 0. So to find the mean of that, it's 0 divided by the number of points you have. So this one would have been 0 divided by 16, which is going to give you 0. That's why we have to square them, is so that we actually get some residual value.
When do you square them? Or
Not
does the
yet.
calculator do it for
Not
you?
yet.
Okay.
Yeah, we're just.
I was just confused because it says all that and it says this happened and I don't know what this was referring to.
Where does it say?
Nothing really
Oh,
before
right.
that.
The regression line minimizes the sum of the residual. If we add up the prediction error for 16 trucks, the positive and negative residuals cancel out. This happened when we tried to measure deviation around the mean. So remember, if you can go back to your chapter 1 notes, when we're trying to find the standard deviation, we had to square to get the variance and then take the square root.
Yeah, I don't remember that much, but I remember it happened, but I don't really remember the details of the variance and stuff.
But that's where it's at. So if you wanted to check
Okay.
it.
I was confused because I didn't know where it was coming from, but
Yeah.
that's all.
No worries.
Thank you.